Hello everyone, and welcome to the video on for section 10.2 on arithmetic sequences and series. These are the sequences where we are always adding or subtracting the same thing. These are when you look at these sequences, these are the ones you would describe where the terms are going up by 4 or everything's going down by 3. Our skill objectives for this video. Number 1, recognize an arithmetic sequence. Number 2, find the general or that nth term of an arithmetic sequence. Evaluate a finite arithmetic sequence. You're not going to be able to find the sum of an infinite arithmetic sequence, so we don't have to worry about that. And we want to use arithmetic sequences to model problems. The conceptual objective for this particular video is understand the difference between an arithmetic sequence and an arithmetic series. Before we move forward, we really must go and get a definition for an arithmetic sequence, what it means to be an arithmetic sequence. So, a sequence is arithmetic if the difference between any two consecutive terms is constant. In other words, if I take a2 minus a1, that's going to give me the same thing as if I take a3 minus a2, and that will always be the same no matter what. If I take a sub n plus 1 minus a sub n, those differences will always be the same value. They will be d. So, and that value d is called the common difference. So one of the things they ask you to do is they ask you to determine if a sequence or if a given sequence is arithmetic. And what that means is you're going to go through and you're going to identify the differences between the consecutive terms. And if they are the same, then you would say, yes, it is arithmetic. If they are different, then it is not. For example, let's look at the sequence 7, 2, negative 3, negative 8. I want to go and determine if it's arithmetic. Well, the first thing I do is I'll take the difference between the first and second terms. So the second term is 2. So a sub 2 minus a sub 1 is going to be 2 minus 7, and that's equal to negative 5. I'll do the same thing with a sub 3 minus a sub 2. A sub 3 minus a sub 2 is negative 3 minus 2, and negative 3 minus 2 will give us negative 5. So again, those two have this. So far, it appears like we do have a common difference. And we do the same thing with the a sub 3 minus or a sub 4 minus a sub 3, which will be negative 8 minus a negative 3. Which will be negative 8 plus 3, which also equals negative 5. So therefore, when I look at the given information, I know that all the common differences here are equal. And so I would assume that this sequence is arithmetic and d is equal to negative 5. What I'd like you to do right now is I've given you another sequence. That sequence is 1, 5/3, 7/3, 3, so forth. And I would like you to determine if that is arithmetic. So pause the video, identify the differences between the consecutive terms. If they are the same, then it is an arithmetic sequence, and you'll tell me what d is. If they're different, then the sequence will not be arithmetic. So I'd like you to go through, pause the video right now, determine if this sequence of 1, 5/3, 7/3, and 3, if that does seem to represent an arithmetic sequence. Welcome back. In this case, you should have found that this sequence is, in fact, arithmetic. If you take 5/3 minus 1, that would be 1 over 1. We get a common denominator. That's 5/3 minus 3 over 3, and that will give us 2/3. Do the same thing with the next two. You have 7/3 minus 5/3. That's fairly quick. We can see that is also 2/3. And if you went through and did 3 minus 7/3, you can go through and get that is arithmetic as well. Or that's also will be equal to 2/3. So in this case, this sequence does represent an arithmetic sequence right there. And our common difference, in this case, d is equal to 2/3. Now what we want to do is develop a formula that we can use to identify that general term. Arithmetic sequences are nice because of the way they are formed. They do actually have a very nice, easy general formula for us to work with that will help us find that be able to use these things and be a little bit more faster with it. In this case, what you have to remember on this, the way a arithmetic sequence is developed is you are always adding that common difference, that d value, to the previous term. So in the first case here, I know my first term is a sub 1. So my second term is going to be the first term plus d. Now to get to the next term after that, I'm going to add another d to that. So that's going to be a sub 1 plus the 2d. And if I add another d to that, I get a sub 1 plus 3d, which would be a sub 4. And if I add another d, I'll get a sub 5, which would be a sub 1 plus 4d. Now what I want you to do on this one, remember when we work with these general terms, you really want to go and see if you can identify a pattern. And there is a very nice pattern here. You'll notice that in this case, the general term a sub n is going to be, well, you'll notice that every one of these does contain the first term, so it's a sub 1 plus some value times d. Now I'm going to start here at, let's go to the third term. When n is 3, I'm adding 2d. When n is 4, I'm adding 3d. When n is 5, I'm adding 4d. You notice that the constant, the coefficient on d, is always 1 less than the term number. And so therefore I would say a sub n is equal to a sub 1 plus n minus 1 times d. And as you work your way back, that also still holds true. Because in the second term, that's a sub 1 plus 1 times d. And in the first term, that is a sub 1 plus 0 times d. So when n is 1, I get 0d. When n is 2, I get times 1d, adding 1d, and so forth. So my general term on an arithmetic sequence is this term right there. A sub n equals a sub 1 plus n minus 1 times d. So a couple of types of problems they're going to ask you to do on these. Number one, they're going to ask you to find a specific term number of an arithmetic sequence. And number two, they're going to ask you to find the general term when you're told some information. Well, in terms of to find the 30th term, I do need to identify that general term. Now, one thing I'm going to have to do is I have to remember that my general term, a sub n, is equal to the first term plus n minus 1 times d. So what I have to do to find the general term, I just really need to identify the first term and the common difference. Well, in this case, in this sequence that we have, it's very easy to see the first term because it's in the sequence it's given to you. I know in this case that a sub 1 is equal to 3. Now, in terms of this sequence, I look at this to go, if I take 10 minus 3, I get 7. 17 minus 10 is 7. 24 minus 17 is 7. So that leads me to the idea that d is equal to 7. And so, in this case, my general term for this sequence is a sub n equals 3 plus n minus 1 times 7. Now they want me to find the 30th term. So to find the 30th term, I'm going to put 30 in for n. So a sub 30 equals 3 plus 30 minus 1 times 7, which will be 3 plus 29 times 7. And that will be 3 plus 29 times 7 is 203. So the result is this is 206. So in this case, I know that a sub 30 is equal to 206. The 30th term of this particular arithmetic sequence is going to be 206. Now in the next one, what we have is they're giving us information about the sequence. In this case, they tell us that the 7th term of the sequence is 26, a sub 7 is 26, and a sub 13 is 50. Now what you have to do on this, you have two pieces of information you have to find. Number one, you have to identify you have to find a sub 1, and you also have to find that common difference. So the first thing we're going to do is find the common difference. To do that, I need to think about how we generate the terms of an arithmetic sequence. And we do that by adding d. So that means that I know that my 13th term, a sub 13, is going to be a sub 7 plus some multiple of d. In this case, to go from the 7th term to the 13th, just really subtract the two term numbers. There's 6 terms there, so it's going to be a sub 7 plus 6d. And now I can use that information to solve this problem because I know a sub 13 is 50, so I know 50 equals 26 plus 6d. I subtract the 26 from both sides. I get 24 equals 6d, divide by 6, and I find that d is equal to 4. So in this case now, I know that a sub n is equal to a sub 1 plus n minus 1 times 4, because that's d. And what I can do now, I need to find the first term. And to do this, I just need I can use either one. In this case, I'm going to make my life easier. I'm going to use the 7th term. So I know when n is 7, I know that I know that 26 is going to be a sub 1 plus 7 minus 1 times 4. Which that is, so I know 26 equals a sub 1 plus, when I add these, when I multiply this out, 7 minus 1 is 6, 6 times 4 is 24. And so solving for a sub 1, I just subtract 24 from both sides. I know a sub 1 is equal to 2. And so I can say on this particular problem that a sub n is equal to a sub 1, 2, plus n minus 1 times 4. This would be the general term of our sequence that has a 7th term of 26 and the 13th term of 50. Another thing they're going to ask you to do is to identify a partial sum of a sequence. And to do that, I just want to go and try to develop the formula here. In this case, I know s sub 6. I'm going to take the first 6 terms here, and I've listed them off. Yes, I have the ... that this does continue on. But really, we're just going to look at the first 6 terms here. And I want to identify the sum of this. Now, when I just take my calculator out, add them up, I will get that sum is 72. But I want to have a formula because a lot of times, sometimes that's not going to be as easy to work with. So one of the things I have with this, some patterns I want you to recognize here. If I take the 2 middle terms, 10 and 14, and I add them together, you'll notice I'll get 24. If I go and take the 2 terms that are on the after that, so in this case the 6 and 18, and I add those together, I will also get 24. And if I take the last 2 terms and add them up, I will also get 24. And so in this case, I know that the sum of these 6 numbers would be 24 plus 24 plus 24, which happens to be 3 times 24. And so I can say s sub 6 from this is equal to 3 times 24. The question then becomes, where did these different numbers come from? Well, first the 3. We're taking, in this case, I wanted the sum of the first 6 terms. I have 3. In this case, that 3 is there because it is half of the number 6. So I know s sub 6 here is going to be 6 divided by 2 times 24. And the next thing we have is where's the 24 come in? Well, I have 3 pairs of numbers up here that add to 24. And the pair that I want, though, is going to be the fact that that is 2 and 22. And what's special about those is those are the first and last term of the partial sum. So I have s sub 6 equals 6 over 2 times 2 plus 22. Now I want to use this to go through and get a partial sum formula that we can use whenever we're asked to find the sum of the first n terms. So in this case, s sub n, we want to come up with a formula for that. Well, let's start out looking back here. And I had s sub 6, and I have 6 over 2. So in s sub n, that's going to be n over 2 times. In this, the 2 happened to be the first term, and so that would be a sub 1 plus. In the 22 happened to be the sixth term, which is, not coincidentally, the number that we have there. So in this case, it is going to be a sub 1 plus a sub n. And this is the formula that we will use to find the sum of or the partial sum of an arithmetic sequence. Let's take a look at a problem here. In this case, they give us this problem here. They want us to find the sum as k goes from 1 to 20 of 2k plus 1. Well, this is an arithmetic sequence. What they're asking me to do is they want me to find the sum of the first 20 terms of that sequence. So we know the sum s sub n, the partial sum, is equal to n divided by 2 times a sub 1 plus a sub n. So s sub 20 is going to be 20 divided by 2 times a sub 1 plus a sub 20. So I know in this case I just have to identify the first and the 20th term. Well, over here I know that my general term for the terms of the sequence are going to be 2k plus 1. So if I want the first term, I just have to put 1 in for k, which will give me 2 times 1 plus 1, which will be equal to 3. If I want the 20th term, I'm putting 20 in for k. So I get 2 times 20 plus 1, which gives me 41. And so my partial sum, the sum of the first 20 values of this arithmetic sequence, is going to be 20 divided by 2 times the first term plus the 20th term, which would be 3 plus 41. I go through and simplify that. 20 divided by 2 is 10. 3 plus 41 is 44. So I have this s sub 20, that 20th partial sum, the sum of the first 20 terms of our sequence, is equal to 10 times 44. And 10 times 44 does come out to be 440. So s sub 20 here is equal to 440. Another way they'll do this problem, the same type of problem, is to find. They'll tell you to find a partial sum for a given sequence. Now notice the difference in this one. I'm not giving it to you with the sigma notation, so I don't know the general term, which is what I'm going to have to find to start out with. So in this case, when I look at this one, I know that the first thing I have to do is find that general term. And I know my first term in this case is 2, sorry. And I know, looking at this problem, I can identify that the common difference is 7. So for this particular problem, I can say that my general term, a sub n, is equal to 2 plus n minus 1 times 7. So if I want to find s sub 25, I know that s sub 25, the sum of the first 25 values of that sequence, is going to be 25 divided by 2 times the first term, a sub 1, plus the 25th term, a sub 25. Well, the first term, again, I already know what it is because the sequence has been given to me. I know my first term is equal to 2. And so the only thing I have to do is find the 25th term. Well, I know that in a sub 25, I have my general term, a sub n equals 2 plus n minus 1 times 7. So I know a sub 25 is going to be 2 plus 25 minus 1 times 7. So I take that and calculate. I need to calculate that 25th term. So I'm just going to go through and do that. I take, that's going to be equal to 2 plus 24 times 7, which comes out to be 168. So this sum, the 25th term of our sequence, is going to be 170. So that our 25th partial sum comes out to be S sub 25 equals 25 divided by 2 times 2 plus 170. So that'll be 25 over 2 times 172. And at that point, I just need to go and evaluate that. I can do the calculator, or I can go and do it by hand. Either one will work. These are not horrible numbers. And that will come out to be 2150. 2,150. So the sum of the first 25 values of this arithmetic sequence up here will be 2150. 2,150. This now does conclude my video on the arithmetic sequences and series. We will look at do an example of an application problem in class, but again, it really comes down to, with the arithmetic sequences, that you be able to find the general term and use that general term to find a specific term number, or to find the partial sum of an arithmetic sequence. Every problem is going to break down in that respect, and as long as you can identify the pieces of information you need for those formulas, you should be in good shape. So with that, I hope that the juniors, that you are having a nice time after all the testing we've done. And with that, we will see you at the next class, where we'll deal with more problems with the arithmetic sequences. So have a good weekend, and see you in our next class.